dialing in for Buckle Up for CRT Management. I'm Ben Parker. Thanks for the introduction, Richard. I am Engineering Manager for TEX, Track Engineering Construction Services, engineering, permanent way engineer for just over 20 years now in various different guises, on National Rail, been involved with DLR and trams as well. And like Richard said, it's quite a timely sort of introduction to CRT this or talk on CRT, given that where I am in Essex today, the air temperature's about 33 degrees. At Lenham yesterday on one of our sites down in Kent, the air temperature reached 28 degrees and the rail temperature peaked at 49 degrees, which is quite relevant to what we're about to talk about today. So, quick agenda for this presentation. There is a lot to fit in, so it does sort of go through at quite a pace. I'll start with an introduction video, then we'll have what is CRT, why is it important, what types of work affect CRT, how is CRT governed and implemented, how we at TEX can support all of these things, and then we'll have questions at the end. This introduction video we start with, one of my favourite films is Saving Private Ryan, and it kind of adopts this reverse chronology type arrangement where the very first scene, for those of you that haven't seen it, is an old chap visiting a war memorial grave, and it just sets the scene for, it's kind of the end, it's the end of the timeline, if you like, and this introduction video sort of adopts that process as well. It shows us what goes wrong when we don't follow processes, when we don't adopt safe working practices, and sort of what the end result is if we get it wrong. So enjoy this, and I'll be back in a minute. Is it not?
Yeah.
Yeah, okay. That's weird, isn't it? Oh, I'll tell you what. Oh, what happened there? Has it stopped?
It has stopped, yeah.
Oh, I don't know what's gone wrong here. Give me 1 second while I try and sort this out.
Is there sound to your video, Ben?
It's not coming through, is it? Yeah, that's what someone just said to me.
So you need to stop sharing your screen, and then when you click to share, there's a setting at the top that you click share sound and video.
Okay. Oh, include sound. Thank you. I told you I weren't very good at this, didn't I? Right.
Not a problem.
Thank you for your help. I'll just come back to the start of that then. How's that? That's not loud. Quite loud. Ah. I'll leave it like that. That video is actually, I can't take full credit for that video. Some of you may have even seen it before because it's been used in previous CRT briefings. Not all the incidents shown there either were CRT related. It was more a demonstration, particularly Hatfield. It was more a demonstration of what goes wrong when you don't follow the process, when you don't follow the standards, etc. So let's have a look in more detail about what is CRT. So we start with our problem statement. So rail is made of steel and installed predominantly in areas affected by large temperature variation. So the temperature can range between sort of -5 and 50 degrees C. That's not exact. That's the approximate range that we get in this country. Rail is subject to the effects of thermal expansion, but it is constrained typically every 600 to 700 millimeters longitudinally by fastenings with tow loads of in excess of 10 kilonewtons. That's our sleepers and our fastenings, pandrol clips, etc. As the rail temperature rises, the compressive forces increase linearly. There comes a point where the compressive force will exceed the combined restraining force of the track system, most likely resulting in a sudden lateral and occasionally vertical shift of track, what we often refer to as a track buckle, the consequences of which can be catastrophic. Critical rail temperature management and application not only reduces the risk of this happening, but it mitigates the consequences when it does happen. So there's two standards, or two main standards, that govern how we sort of manage CRT. One's a predominantly maintenance standard and the other one's a project standard. First one, Mod 14, defines critical rail temperature as rail temperature calculated to trigger mitigations for track. And the project standard, CRT management for projects, says that it's the rail temperature to which track is allowed to rise before specific measures to protect traffic are required. Both essentially saying the same thing, calculation of a rail temperature before we have to do something to mitigate the risk. So let's just remind ourselves quickly what track is. It's a common sort of fault that rail and sleepers is what makes track, but we have to consider all these other things as well. So the ballast beneath the sleepers, there could be a separator between the ballast and the ground beneath. The formation and the subformation all constitutes part of our track system, and it's all part of what we have to think about when we think about CRT management. So to understand what CRT is and how we calculate CRT value, we need to know a few more terms. There are two basic types of rail configurations in use on network rail infrastructure, and that's jointed track and CWR. Jointed track is track installed in relatively short lengths, joined at the ends with fish plates and bolts to connect one rail to the next. Thermal expansion gaps are set dependent on rail temperature between the rails to allow them rails to breathe and contract and expand with the variation in the rail temperature through the seasons. Continuous welded rail is the second type of rail we use, and that's rails joined longitudinally by various welding methods to form continuous lengths without interruption, so taking away the need for joints. So now we understand the two types of track. There's a couple of other terms we need to get used to, and that's the stress-free temperature. This is applicable to CWR. It's the rail temperature at which the rail is the same length as it would be in an unrestrained state, and at which, therefore, there is no thermal force present, or the temperature at which there are no compressive or tensile forces present in the rail. If you think of a section of rail keyed down to sleepers, at whatever temperature that's at, if we unkey that rail and it doesn't move at all, whatever the rail temperature is at that point, that is the stress-free temperature. That's kind of explained in its most basic form. Instead of FFT for jointed track, we have something called a joint closure temperature, and it's applicable to jointed track. This is the temperature for a section of track at which a number of expansion joints close to a zero gap. So the temperature at which the rail rises, the point at which all those gaps close up, is what defines the joint closure temperature. At the point at which all those joints close up to a zero gap, the track then starts to act like CWR. And it's a common misconception. It's not so much these days, but it can be still. The point is CRT management and the effects of thermal expansion is applicable to all types of track. That's CWR and jointed track. So why is it important then? So like I said before, It's mandated through 2 of Network Rail standards and ensures the safety of the line when managed correctly. That's that mod 14 on the left, the maintenance standard, and the project standard on the right there, 7012, draws a lot on the clauses within mod 14, but has some slight differences in the way the process is managed, fundamentally achieving the same result though. Quite simply, it is important to manage CRT well to avoid track buckles. A track buckle is a sudden shift of track that misaligns the geometry to a point where there is a high risk of derailment. Track buckles are normally experienced laterally, but there can be vertical shift also. These can result in fatalities, injuries, damage, and/or delay. Also, though, when we manage the process correctly, with due care and consideration taken at the earliest opportunity in the planning stages, we can actually save money, reduce risk, and minimize disruptions. So, for example, planning of CRT affected works through colder seasons is a far better way, a far better process. It's not always possible to do that. Sometimes we are constrained by access opportunities and staging of the works. But if we can have that forethought in the early planning stages, we can far better sort of manage the CRT process and reduce risk, reduce the need to put speed restrictions on, and reduce cost, etc. So these couple of videos, short videos we've got coming up now, is just some examples of a couple of examples of what track buckles actually look like. I'm not sure of the origin of this video, but it is quite old. It predates AI, so it is a real situation. And I believe I've been told previously, but don't quote me on it. This was set up in like a to do this in a test environment, if you like. But what you can notice on the right there is no ballast shoulder, lack of ballast in the sleeper beds, and it's no surprise that with no lateral stability there, that buckles happened. That video is not sped up at all even. That is how it looks. The second video is a cab ride video. It's only short, and the result of when a buckle happens, or one of the results. Doesn't get a lot of opportunity to see that before the train's on it. That train's not really travelling all that fast. Travelling even slower now. It's derailed. I think some of the bogies have derailed there. But that's an example of what a buckle can look like. Oh, there it is again. Right then, what types of work affect CRT? This is the important part. This is what we really need to understand, because this is sometimes where projects and planned works can trip up. To understand what types of work affect CRT, we need to understand a couple more terms. First one being the track support zone. It's a railway specific term, and it's any area beneath the track that supports the position of the track. So it's sometimes better to see things in a diagram than lots of words. This is essentially what the track support zone looks like. This is a twin track example. It can be applicable to single track or multiple tracks. And everything below that dotted blue line is part of the track support zone. And like the note says, it extends down indefinitely. You've got these 45-degree theoretical lines coming off either side. Any physical works that encroach within that boundary will be subject to CRT management, or at the very least needs to be considered in the planning phase to understand the impact and whether or not, or the way that the process needs to be managed. So that's one way we define what affects CRT, the type of works that affects CRT. The second phrase we need to think about, it's not railway specific, it's the zone of influence. So when we think about the zone of influence, before relating it to the railway or thinking how it interacts with the railway, we have to understand what it is. It says there, and that's a definition taken out of Civ 177 standard. The area in which an activity or pressure could directly or indirectly impact part of the environment. The extent of the zone of influence can only be defined by the designer. The CEM, the contractor's engineering manager, will advise if the works are in the zone of influence, but check every time that you know how far it extends. A better way and a more basic way of describing a zone of influence is think of the activity you are undertaking. It will affect a physical area of the work activity, but then you need to think of the area around the activity that is affected by that activity, and that defines your zone of influence. And that's something the designer will tell you for whatever activity you're undertaking. If the limits of the zone of influence encroach upon the envelope of the track support zone, then a CRT assessment needs to be made, and we need to follow those CRT processes either through 7012 standard or the Mod 14 standard. So again, lots of words there, but sometimes a diagram helps better. The slide as you see it now kind of shows some sheet piling happening down the bank in the cess. Those sheet piles have been driven to depth, and we can see that physical works have not encroached upon the track support zone. So from this information here, we could make an assumption that, okay, CRT management's not required because we've not affected that area. But when we think of the zone of influence from the piling because of the vibration, etc., and it extends to that crude animation, if you like, we can now see clearly that those works do encroach upon the track support zone. So now we understand that we have to start following the rules that are dictated by those standards, filling out assessment forms, planning for it, and managing it suitably. Give you a real world example as well. This was a job I worked on back in 2011, 2012 on a DLR. That's Custom House to Royal Victoria Dock Stations. It's got quite a nice alignment between the two stations there, but because of Crossrail, they had to shift their whole track to that rather cumbersome arrangement. So the track got realigned to what you can see on the screen now to enable the Crossrail portal to be installed above it there, which you can see in that slide. As part of those enabling works, once that track had been shifted, sheet piles were driven in roughly where that dotted red line is. They were installed between 8 and 10 metres from track, so quite some distance really, but they were driven from memory, I think it was over 12 metres, 12 to 15 metres varied. I had the job of handing that back at the end of the Christmas blockade on a Boxing Day, and when I went out, it turned out that the track had shifted over 100 mil laterally and vertically, all down to that piling. The result of that, or that lack of understanding of quite how intrusive that works was an overrun of 5 mile an hour emergency speed restriction that ran for 1 week while they carried out rectification works on nights, and a 18-hour Boxing Day shift for me, which was fun. So this is what happens when we don't fully appreciate the nature of our works and how it can impact the railway. So then, what types of work affect CRT? So the 7012 standard lists a number of activities. It's not exhaustive, but it is a good indicator of the kind of works that affect CRT or require CRT management. There's the obvious ones like track renewals and remodelling, installation of rail joints and closure rails, lifting and lining of track, or the installation of cable management sleepers into existing consolidated track, and other similar isolated disturbances. But then there's the less obvious ones, the ones where we're not quite physically within that track support zone, we're close to it, but the stuff that can extend or affect that track support zone, recovery of troughing routes, drainage works, any works elsewhere in the railway system that could affect the stability of the track, e.g. piling. We've already looked at that example. Line side or under track excavations. Sometimes people forget that it extends down indefinitely. Doesn't matter how deep you're excavating. If you're going under the track, you're in the track support zone. Temporary or permanent works requiring temporary removal of the ballast profile, e.g. construction of platforms, signal bases, under track crossings, or other structures. So remember, if the zone of influence of the works encroaches upon the track support zone, a CRT assessment is required. The zone of influence is dictated by the designer. Whether it encroaches upon the track support zone is often assessed by the contractor's engineering manager. So stop, think CRT. CRT management begins at the planning stage. Like I said at the very start of this presentation, it's quite a good day to present this given how lovely a bank holiday weekend we've just had. But if you're thinking about it now, you're probably thinking about it too late, in all honesty. These things should be thought about way in advance in the planning stage, so we can prepare for it, plan for it, and mitigate against the risks, etc. How is CRT management governed and implemented? As mentioned previously a couple of times now, there's two standards. One's predominantly for maintenance, the other one's more for projects, but draws a lot on the detail contained within the maintenance standard. Supplementing these standards, there is a number of track engineering forms, TEFs, which to be used to ensure the correct application of the standards. These forms are used throughout the CRT management process to demonstrate compliance, enable works to be planned and undertaken successfully. And these are some of the forms just popping up on the screen there. There's a whole load of them. They're all detailed within the standards, and they start at the planning stage all the way through to undertaking the CRT management and closing it out at the back end. That's the process flowchart that's shown in 7012, and we work it through from the planning stage all the way through to completion of the work and the post-works requirements. But essentially, that process flowchart tells us about the planning phase. We identify any types of works that will require CRT management and plan accordingly. It may be prudent to consider the time of the year that these works are delivered. Like I said earlier, it's not always possible to do that, but it's well worth considering those things. CRT pre-assessment forms can be generated to fully anticipate the level of CRT management required, looking at forecasted air temperatures, etc. as well. Then we move on to the construction phase. We complete the planned works and we generate final CRT assessments as dictated. Immediately post-works, all CRT sites get entered onto the CRT register and we manage the process from there. Manage CRT sites accordingly until transient end dates or full consolidation of the affected track support zone is achieved. Where required, we react to CRT trigger breaches, deploying watch people or smart watch systems and applying ESRs. And upon completion, we archive and remove all the sites once they've expired, once they've reached their end dates, and maintain records of evidence as evidence and assurance. So instead of using, in this previous slide, you'll see that thermometer that requires someone to actually go out on track and take rail temperatures. We do have the option of these smart systems nowadays, one of them being remote temperature monitors. And there's an extract from one we had at Kennedy Road last year in the middle of August with rail temperatures peaking at over 50 degrees. So there's an example of a form that has to, an assessment form that has to be filled out. There's 1, 2, 3, 4. There's 5 different forms dependent on the track configuration, whether it's jointed and the type of work that's been undertaken or the type of disturbance that's been experienced. In order to complete a CRT assessment form and calculate CRT values, the following information must be available. We need to know the SFT or the JCT for jointed track if it's not CWR. We need to understand the horizontal radius for the track geometry. The tighter the radius, the bigger the risk of track buckle. What type of ballast we have out there, what sleeper bearer and quantity per length, the rail and sleeper and bearer type, and what track condition code the particular site has experienced. All of these factors that are shown on the screen now, along with a couple of others as well, will dictate how much you need to adjust your CRT trigger value by. The more risk imparted by the different conditions means that value will decrease more and more and present more of a risk of triggering a watch person or a speed requirement. With these parameters confirmed, an output value for the following control measures can be achieved. So there was a recent change to the maintenance standard where they now define the different control trigger temperatures as CRT 1, 2, and 3. Slight change there. The project standard 7012 still sort of identifies the need for the temperature at which there's a need for a watch person, the temperature at which there's a need for a 30/60 speed, or the temperature at which there's a need for a 20-mile-an-hour speed. Imposing these speed restrictions doesn't necessarily prevent the track buckle. It mitigates the risk of if a track buckle happens. If you do drop the speed to 30/60, then the lateral forces can be or are less, so the chances of a buckle will be reduced. That requirement to drop down to 20 miles an hour gives the driver more chance of seeing the track buckle in time, stopping the train in time, but also again it reduces the lateral forces that could trigger a track buckle as well as the temperature rise. So that's an extract from one of the tables where we draw our adjustments in the trigger temperatures. On the left-hand side, we've got a column there where we work out what track condition our site is under. It's just an extract, it's not a full sheet. And then they've got 3 columns that tell you how much you have to adjust your SFT by, or it would be the JCT if it was jointed track, to work out what your trigger values are for your rail temperatures. On the right-hand side, it dictates how long that site has to stay on the register for, dependent on track category or the particular condition being applied. So like I said, it's a bit of a whistle-stop tour. I have to try and squeeze it into a reasonable time frame. I don't think I've done too bad considering the audio problems I had at the start. So just a couple of things as we come towards the end of the presentation. Remember, CRT management begins at the planning stage. And I say remember, it's applicable all year round. I think that's the first time I've actually mentioned it. CRT management is applicable all year round. It's most risky in the hot season, which in the standard is defined as mid-March to mid-October. But we still have to apply the process all year round regardless. And that's quite a cliche at the bottom there. Fail to plan, we plan to fail. But it is very quite true. In terms of techs, how can we support with this whole process? We give full support to this CRT management process. We have the capability to cover every aspect of it, from the early planning stages all the way through to implementing it, undertaking it, and yeah, we offer like a one-stop shop type service in that sort of regard, or as little any part of that we can support with that as well. So thanks for listening, but we aren't just a CRT management company either. So if you'll just enjoy this last little video before we open up for questions, and it will explain a little bit more about what else we do at Tex. Thank you. No, I'll have a look now. Oh, on it. Oh no, done it again. I said that was that does go at quite a pace, that presentation. It'd be nice. I'd like to present that in more of an hour slot and take my time a little bit more, but I'm happy to sort of go into some questions now.
Thanks, Ben. That's been it's been really good. I think actually one of the things for note for me of this is once it's recorded and on the Knowledge Hub, I think I'm going to get all the graduates and people I have passed through the team to have a bit of a look at that, because it's a really good introduction to hot weather and something I think you've explained much more concisely than I have. So thank you very much for a really informative conversation. We'll go to some questions. As I said earlier, if people want to put their hand up and ask something, I'll introduce you and let you come in. If not, I'll start working through the ones in the chat now, and we'll have a bit of a rattle through. So first one in the chat is from Satish. How is how does the CRT affect the turnout zone, and what provision is required which doesn't affect point operation?
Are you talking about, I assume that means turnout through S&C?
Yeah, I think that's the gist of it, yeah.
I'm not entirely sure I'm not 100% sure what the question is, but I'll go down the route of what I think the answer is, and you can always ask to rephrase the question if you need to. It's applicable for S&C, and the standards and the forms have sections that in relation to S&C of what we have to do and the way we manage it.
Go on, Satish, if you want to jump in there.
Yeah, Mr. Bin, can I ask that question?
Yeah, if you carry on.
Yeah, Mr. Bin, my question is that since we are doing the CWR is the major critical point is the CRT temperature on which we are doing the joints welding. Okay, so when we are doing the same joints or welding in the turnout zone, so what are the provisions required to be functional of the CWR in turnout zone? And when we provide anti-creep device in the turnout to behave the turnout functional properly, so what should be the precautions should be taken? Did you get my question?
I'm afraid I'm not sure I fully understand what the question is, Satish, to be honest with you.
Mr. Ben, I will repeat it again. At one side, that is the SRJ of the turnout. That side, there is a switch and lead portion. So that part of the CWR behavior is being controlled with the provision of the anti-creep device. Okay, and at the other side, crossing is there. So how the CWR affects the rail behavior?
Are you you mentioned the tunnel? Were you talking about in the tunnel or outside the tunnel?
Not turnout, switch and crossing, SNC.
Yeah, I'm not. I don't know what the question is, and I'm not sure what the answer is. I wouldn't want to say something that is wrong, to be honest with you. I don't know, Richard. Do you?
Okay.
Yeah, so I think in terms of what you're thinking about there, Satish, is it in terms of actual how the turnout is managing the creep of rail? So in your switch end, you've got your ball and claw, or your stress transfer block mechanism, and then at the crossing end, the crossing is kind of your big heavy anchor, isn't it?
I would suggest that it's not. I don't think that's a CRT question as such. I might be wrong, but in terms of we still have the CRT managed through S&C, and we still adopt the same process that is dictated in standard. If we're talking about an interface between where you've got CWR with maybe some unstrengthened S&C, or you're going into jointed track, then you take the worst case scenario. Any CRT site can be broken down into distinct elements as well, so you don't have to cover one site with one temperature. You can do multiple assessments if they vary vastly, but you have to question whether is it worth doing multiple different forms and managing multiple different sites, or do you just take the worst case scenario for that whole site and apply it across the whole site? It's one of the main points I always do in a lot of the presentations I do and a lot of training I do is most of this can be related back to the planning stage as well. If you don't identify this at planning stage, then it's going to cause you a whole world of pain later on. If you identify at planning stage, you get the right people involved, and you can make sure that you're working in the safest way possible, but also taking the time to you might be able to expedite the works, but you might be able to save money. So the planning enables all of that. Good planning enables all of that. But a good plan is only good if you can cascade it down to the site team as well. No point having a good plan if no one knows about it.
Brilliant, yeah, and that's my thoughts as well in terms of management. S&C, plain line, we treat it all in one way, and it's all managed under that blanket. So yeah, no, thank you for that, Ben. So second question is from Dermot. What are your thoughts on training and competency regime for CRT management?
It's a good question actually, because some of it, some of the stuff is it's well controlled. In that, one of our guys went on the CRT management training last week on a Monday, Tuesday. One of our engineers, we're quite trying to upskill him a bit, and that was one of the things that was developed as one of his learning areas. So he went and done a 2-day CRT management course. Some of it is internally assured, dare I say it. Some of the processes, like filling out the assessment forms, that sort of thing. I don't think it's too bad, to be fair. But it relies on, for example, us within tech to make sure that our processes are correct in terms of mentoring those guys and teaching them. I think a lot relies heavily on the company involved that are sponsoring these people that supposedly are deemed competent, etc. But I think generally speaking, the correct training is available for the high level competencies.
Okay.
Everything's got room for improvement, though. Always.
Always, yeah, absolutely. We should all be striving to improve, definitely. Next question from Matthew. How does the standard CRT plan account for localised increases or decreases in lateral force, i.e. slab to busted track transitions or concrete bridge abutments?
Yeah, so I think with my answer to Satish a minute ago, we kind of touched on that, where you might have a site that's got multiple, it's got quite a wide variety across those different limiting factors, curve radius, basically track type. What else could it be? Can't even think now. You can either break it up into individual elements, or you take the worst case scenario. And it depends. There's pros and cons for both approach, but again, sit down, look at that during the plan, and work out what the best way forward is. I think that's what the question Matt's posing there.
Yeah, that's great. And the next one, so Chris says, great presentation, Ben. What's your view on taking CRT readings at the actual locations versus having a rail temperature monitor in the depot on a stillage many miles from the CRT site?
I think it ought to be a hierarchy of a lot of the railway processes are dictated as such, where your best data is going to be at site, 100%. But it's not always possible to do that. The smart systems we have in place, RailSense, for example, have some great equipment that we can deploy them a lot better and a lot easier now and get some real good real-time data. But if you can't do that, then you resort to the next best thing, which is your rail temperature monitoring a depot. Once again, I know I sound like a broken record, but all this should be identified in the planning stage. And therefore, if you're monitoring rail temperature in a depot, you need to be able to mobilise sooner to make sure that you're on site for when them trigger temperatures do hit.
Yeah, no, absolutely. And then next question from Elizabeth, is track buckle risk significantly affected by shrink swell behaviour of earthworks in a clay-rich soil?
That's a good question. My immediate answer is, and my gut feeling is, well, I imagine yes, because it will affect your track support zone. And that's the track support zone is where that risk of track buckle is going to occur. If there's any deficiency or disturbance within that, then yes, it will affect that.
Okay, and then Simon's just offered you a little point of clarification here in that Mod 14 is the Watt standard in the level 2 in Network Rails hierarchy, and 7012 is the level 3, the how you do it. So I think what he's basically saying there in the next part is that that's perhaps some of the reason for that little discrepancy you picked up on.
Yes.
Because I guess from my point of view, I've always liked CRTW 30 because it tells you go into this. But I think perhaps the point of change, maybe why they've done it, is we could actually do something different, couldn't we? It's loosening that up a bit and taking some of the shackles off, which is perhaps something we need to do with standards, to think actually what do we want to do to risk assess at those 3 points. But quite an interesting one.
I appreciate that, Simon, actually, because I literally had this discussion in the office this morning about that, the frustration of 001 being updated, but 7012, which draws heavily on 001 or mod 14, sorry, and 7012 kind of contradicts it a little bit now because the processes don't align. And I hadn't taken note of the whole level 2, level 3 thing at that point. So that's a little bit of help for me there. So thank you. And
then one from Stuart. How does the zone of influence for works around the railway operate when you have a track that is currently not in use?
I suppose it depends what you define as track currently not in use. If it's out of commission, then I dare say, I mean, again, you'd need to find out in the planning stage, but yeah, I'd say track that's out of commission then probably doesn't. I don't know the definite answer, so I wouldn't want to give you a definite answer, but my gut feeling again would be out of commission wouldn't need to be CRT managed. If it's out of use unofficially, then it 100% would need to be CRT managed. If there's a potential for that track to still be used, you've got to follow the process.
Yeah, and as asset owner for Northwest, that'd align with kind of my opinion for here as well. So I can't speak for the rest of the country, but that would definitely be the approach I'd take, Ben. So that makes sense. And then the next one from Stephen. In Scotland, we've used white paint to help, and I think we've done that quite a lot nationally as well. Cool rails in extreme hot weather. How effective do you think this measure is?
Yeah, I think it's proven to be effective. It's used down here as well. But point to note on that is when you're taking rail temperatures, etc., if you're using like a probe or one of the smart systems, you don't put it on a section of painted rail or treated rail in any way. You need it on the shaded side or the side not affected by weather, to be specific, of an untreated or unpainted rail, because otherwise you'll get a false reading.
So then one from Liam. As a London Underground worker, what is Network Rail's guidance, lesson learned, if any, for management of CRT? So again, this is transition zones. This is probably similar to one we've answered earlier. So anything further on that? Or?
Well, the only thing I say that because he's put e.g. tunnel portals is it's clearly defined in the standard that it extends CRT more. CWR, stressing of track, etc., extends 14 metres beyond the tunnel portal into the tunnel. Beyond that, I can't remember what defines the length of a tunnel now off the top of my head, but beyond that, if it is a tunnel, beyond that, it's not it isn't governed by CRT standards, etc. It's governed slightly separately, slightly differently. You don't stress the track, you put the rails in, you allow them to acclimatise to the temperature, and you still have to create a stressing record or a record that shows what that ambient temperature or rail temperature is within the track. And it's not ultimately at that point subject to the environmental factors anymore. So therefore, the risks really are negligible for CRT management.
Absolutely, and that's well defined in standards as well. So it's one you can potentially have a little look at if you wanted to, Liam, in Network Rail standards, which does define the lengths of tunnels and the bits you're talking around. And then next question from Payman. Do you also evaluate different reinforcement approaches, e.g. white painting, sleeper reinforcement, using side end plates, ballast reinforcement, and if so, any feel on which method's been the most effective?
I'm not sure about the most effective method, to be honest. Like I mentioned before, it's proven that painting the rails white does help with in certain situations. Lateral resistance plates obviously help to prevent the track from shifting. They're not designed necessarily for CRT management purposes. They're designed to for tight curves, etc. But I'm not sure about what the most effective is, but they all are effective if used in their own right for the right purposes.
Yeah. Next one from Mark. So from a contracting point of view, it's sometimes nigh on impossible to decide if a CRTW is required. Met Office website has a forecast of 6 days hence, so planning to have a body next to the track is not possible. this is where there needs to be close working with the local network rail DUs. If we were to have a CRTW at Georgeman's Junction by the time I send somebody up from the central belt, the temperature has dropped. Okay, so yeah, I guess a point on the difficulties of implementing there, which I'm sure most of us can relate to.
We all suffer those same frustrations, 100%, yeah. But these smart watch systems, if they come in sort of become more popular and more robust, that might help. But I would say, though, some of these frustrations actually are born out of poor planning. Poor understanding on the delivery, whatever the delivery entity is, poor understanding on their part of CRT management. And hence, this is why we have these lunch and learns. That's why we have these competency training, etc., upskilling of people, so that people are better equipped to plan and get ready for these sort of things. Because those frustrations, whilst they do exist, are exacerbated by a lack of understanding and a lack of knowledge, for sure.
Absolutely. Alex, you've got a hand up. Do you want to jump in there?
Yeah, hello. Ben, you sort of answered in since I put my hand up in a fashion which I agree with, which is that smart technology, AI, call it what you want to these days, but all of that should be a consideration as part of Watchman. Watchman is actually an old term. I've 45 years in the P-way, so watchmen were physically watchmen. I was a watchman myself back in the day, and that, as you say, standing beside the track, watching, waiting for something to happen, and it doesn't, or it may do, is not probably the best use of time, and physically not possible to implement. So I think that the standards and the processes need to embrace the smart technology that Chris and RailSense and companies like that can offer. They need to be incorporated as part of the CRTW process.
Yes. Yeah. Do you know what I was going to say? Because I noticed that Chris is on the call from RailSense, and I would suggest, I don't want to put Chris on the spot too much if he's still on the call, but I imagine, Chris, might you be able to offer something for that? I don't know if that's normal protocol for this sort of thing. I've never presented a lunch and learn before, and you might not want to say anything.
Hi, can you hear me there, Ben?
Yes.
Hiya. Yeah, a great point, Alex. So my understanding is that Mod 14 does embrace a change from the watch person to a watch system, which incorporates smart technology such as a remote buckle monitoring system, buckle sense, for example. So yeah, I think definitely one to look at, and yeah, using the data that's available to help predict when the temperatures are going to reach those CRT critical levels and CRTW. Obviously, it's a very hot day today, and you know, we're sat here watching rail temperatures rise across the country at the moment. I mean, we're seeing some temperatures out in the Midlands in the last hour at approaching 60 degrees. So yeah, I mean, it's pretty good timing, Ben, to have done this today on the hottest May day on record. So yeah, no wonder everyone's interested in what you've got to say. And yeah, brilliant, fantastic presentation.
Thank you.
Thanks, Chris. I did see, Scott, you had a hand and then put it down. Is there anything you wanted to add, or?
No, it was just Chris sort of half answered the question, so I was quite content with that. Obviously, it's part of the planning process, but there's a lot of sites that we have where, you know, it's not just red zone prohibited, but you can no longer gain access to the sites because of the working restrictions. How is that actually managed, not only as part of the planning, but also part of the governance from Network Rail mandating that we can't work red zones, when these situations actually almost dictate that we require that scenario?
Yeah.
You know, I mean, I'm not trying to. I know it's making it safer for the individuals, not dodging trains and all the rest of it. But having worked in the industry for over 35 years, 6 years, whatever it is now, I've come from a background where everything was done red zone, and we never really had the issues that we're currently experiencing because we had systems in place that allowed us to react.
Yeah.
And the systems have become further. I mean, obviously, we work on East Coast Main Line renewals. You know, we cover literally from Berwick to King's Cross and halfway across the country. And we're having to outpost people on a regular basis on the proviso that we're reaching these temperatures. And a lot of these areas, like sort of cuttings and such, where they've done a lot of vegetation clearance, which is great for maintaining the embankments, but that used to shield the track and protect it from the elements from direct sunlight. And we're creating a bigger problem now by removing the vegetation. We've created a heat trap.
I guess from a Network Rail point of view, if somebody needs to go and watch the track, they need to do that behind the passage of a train. So we need to get access to do that. That needs to be granted by signallers, so somebody can go and view it after the train has passed each time, which is how standards set up. If that can't be done, the hierarchy of the standards quite clear. You should go to the next restriction, is my understanding of it. So you should go to your 30 over 60, and if we can't watch effectively, we need to drop to the next safest option. Would be
Agreed,
my approach to implementation for that. Any further thoughts on that, Ben?
No. Yeah, I'm afraid I haven't, Richard.
No, that's fine. I thought I'd probably take that one from a Network Rail side, because it was around kind of our implementation of things, and as you say, you know, changes to working practices, removing red zone and things like that. So, yeah, I think we've probably got time for one more. I've got one here from Molly. In your DLR experience, where you were effectively driving piles deeper than the distance you were from the track, i.e. 45-degree track support zone space, what do you think the root cause of the incident was? P.S. Thank you for sharing so openly.
So, I suppose I have to. I also word my answer a little bit carefully here and tread carefully. It was understood pre-works that the track would be affected by that piling work. So that whole process from the designer of what's the activity, what are the ground conditions, doing all this, all the clever maths that's far beyond my capability, dictate or predicted that it would affect the track, and the track would shift. There was a discord somewhere between a designer defining that and the delivery team on site checking against it. I can't remember what I did last week, let alone the finer details of 2011, 2012. But what transpired on site to me quite clearly was that the engineering team involved were quite surveying and civils biased, with a lack of real understanding of P-way, ultimately. They really didn't appreciate what track was, how it was affected by the works. They went out and surveyed, as they should, as part of the track monitoring. No one processed that data properly, analysed it. They would have identified much sooner that there was that gradual shift of that track. By the time I turned up to do the track and back, it was far too late. They ultimately presented me with a piece of paper, which was mostly a black square, because the Excel spreadsheet had been conditionally formatted to highlight cells amber, red, green, etc., dependent on how much they'd shifted. But their worst case scenario, the conditional formatting for the biggest movement, highlighted the cell black for some reason, which you could no longer even read the number. And that's the point at which I was like, this ain't great. And when once I went out and actually looked at it, you could see it was horrendous, and no one appreciated that. And kind of, they had to be shown and told.
Brilliant. No, that's been really informative. As I said earlier on, you know, something I'm going to share with graduates passing through the team and apprentices and things like that, just because I think you've explained it more concisely than I could, and I quite liked relating it to I try and relate things to Hatfield quite a lot, because I think it affected so much of what we do as track. And I think, showing the similarities there, really good parity at the beginning of the talk. So thank you throughout, and it's been really informative, and for being so open in the questions. I think we got up to an attendance of about 158. I clocked it out, and I'm sure RailEI will send us an official thing at the end of how many hours of CPD and stuff that qualifies for. But that's been really useful. I know we haven't quite got through all the questions, but conscious to keep to time. If you have got anything further, the conversation carries on. There'll be a dedicated area for this on the RailEI LinkedIn page where you can kind of carry on that dedicated discussion. And a final reminder: next Lunch and Learn talk is the 23rd of June, and that's Old Oak Common, an ACOM perspective. So thank you very much, Ben. That's been really great. And you're
Thanks
all welcome to dial off there. No, you're very welcome. Thank you.
Thanks, everyone. Cheers. Bye-bye.
Guys, thank you very much.
Cheers. Thanks.
Cheers.
So,